Hello, my name is Kuncheng. This is homework 7 problem 7 presentation for cost probability and stochastic process. Okay, let's see the problem. The problem provides a function gt equal to n1 t cosine wct plus theta plus n2 t times sine wct plus theta. It's a function, and the theta is uniform in this interval, and the n1t and n2t are WSS, means we have this function according to the lecture is the means n1t equal to mean 1, mean n2t equal to means 2, and the two numbers are constant. Okay, let's do the first question. Is find mean z t. For this one, we just plug in the function is e n1 t cosine wct plus theta plus n2t sine wct plus theta. Okay, and according to the previous lecture, mean a plus b equal to mean a plus mean b. According to this function, we can plug in here, and the this function equal to mean n1 t cosine wct plus theta plus n2 t sine plus theta, and plug in x equal to integral x f x dx. Just plug in here, and we have the, because the en1t equal to mean 1, and similarly this one we can plug in these two numbers here, and we can translate to mean 1 over 2 pi, because the theta is uniform. So plugging the, we can put like here, that is a function ct f u du. This is the function, plug in this function, and we translate to 2 pi because this is the region 0 to 2 pi, and plug in the function theta, this theta, and also similarly mean 2 pi 1 the sine. We can ignore that, it's almost the same here. And because these two functions are cosine and sine, and the region is 0 to 2 pi, that's a 1 period, so they are 0. We just write down here times 0 plus 2 times 0 equal to 0. So that's the answer for the first question. And the second one little bit complex. We need to get r, z, t1, tz, t1, t2, and plug in the function equal to zt1, zt2, and we can write that. Just plug in the function also, like ENT1 cosine WCT1 plus theta plus N2T1 sine WCW1 plus theta, and times is complicated, times also same T1 T2 cosine. Okay, we can write another line, T1 T2 cosine WCT2 plus theta plus N2 T sine WCT2 plus theta. And we can plug in the function. Also, we can expand it, and we can write here, it's too long, N1 T1 cosine WCT1 plus theta times N1 T2 cosine WC theta plus, and plus another one is we T1 T2, and we just cosine WCT2 plus theta plus N2 T2 sine. We just ignore that T2 plus theta because it's too long. I don't want write all of them. Just know that. And we have a third one is EN2 T1 sine T1 plus theta times cosine and times N2, not plus, this is time times N1 T2 cosine something T2 plus theta, and plus another one, the last one is N2 T1 sine WCT1 times N2 T2, this T1, sorry, this T1, and sine WCT2. I don't want write all of them. And next step, we just simplify them. The first one, because we have the of is N1 and the cosine, we just write down here to translate to R N1 tau and cosine. So two cosine T1 T2 something T1 T2, we just simplify them. And the second one is T1 T2 T2. So we just plug in the here, we can get here, we just write min 1 min 2 and E cosine T1 sine T2, because you see that T2 and no, sine T2 cosine T1. And next, the third one is we also this T2 T1 and this one is plus theta and times T1 N1 T2 N1 T2 N1 T2 N2 T1. So plug in here also equal to min 1 min 2 times E sine T1. We just ignore the WCT plus theta. We just write T1 to mark that, and cosine T2 and plus the last one is because it's the same, the N2 T1 N2 T2, so we also can write to the Rn2 tau plus E sine, because they are sine T1 sine T2. And next we just write, just plug in like here, just plug in here, plug in the function to the mean function, like the function here, plug in here, and we have the fu uniform into 2 pi, and we got the function is half n1 tau, and we take the, because fu equal to 1 over 2 pi, I take 1 over 2 pi out of the integral, and the region is 2 pi 0 to 2 pi, and we just simply this one by the like triangle function. Maybe too long, we learned long time before, like you got WC T1 T2 plus 2 theta plus cosine WC tau and no, sorry, we have d theta here, and also we have another one, another function is like this, 2 pi to 0 sine T1 plus T2 plus theta and this d theta minus tau. The function all come from some complex triangle function, and another one is theta 1 and 2 pi. This is, all the things are same. It's same as here, and only plus sine WC tau. And the last one is minus 2 tau, half of n2 tau, and times the 1 over 2 pi integral 0 to 2 pi, and the cosine, all the things same as here, I don't want, and the only difference is minus cosine WC tau. And according to the function, we just can simplify everything, cancel out this one and this one cancel out. This one and this one combines R1 tau plus Rn2 tau cosine WC tau equal to RZ tau. And this one equal to this one, according to the definition of the WSS, WSS means is like wide sense stationary processes. So the ZT, because the ZT is WSS. Okay, that's a question 2. Let's do the third question. Third question is, if ZT is WSS, find the RZ0. This one is easy. RZ0, we just plug in 0 to the answer of the above question. The function is like tau plus 0 to R2 tau and the cosine WC tau. We just plug in 0 to tau, and here Rn0 plus Rn0 Rn2 0 1 0, and because this one is constant, we can transfer to the mean, and we can transfer to the here plus E n2 square. That's a function, and that is this is the answer of the problem 7.